Alright guys, so today we are going to go over some basics of volume. We're moving from two-dimensional shapes to three-dimensional shapes. So, who can explain the difference between, in two dimensions, area and perimeter?
Area is inside and perimeter is outside.
There you go. So if I have this like plot of land, the area is going to be how much grass I can, like if I was laying sod, how much grass I would need. And the perimeter would be how much fencing I would need to close it off, okay? Now let me actually tell you about one of the greatest days of my childhood, since it is Mario Day. One of the greatest days was when the Nintendo 64 came out, which means Mario 64 came out. Do you know how Mario 64 was different than any other Mario before it? It was in 3 dimensions. Not only because all the other ones were just side-scrolling where you'd go left or right or up or down, Mario 64 you could go anywhere. It was amazing. If you haven't played it, you should go back and play it. Now, when we go from 2 dimensions to 3 dimensions with our shapes, instead of talking about area and perimeter, we're going to talk about volume and surface area. So what I want you to do is we're going to do a lot of discussion with the neighbor. So I need you to turn to someone by you and say, what does volume mean and what does surface area mean? If you don't know, we'll see if your neighbor knows, okay? 20 seconds, go. Louise, you need a buddy to talk to. Brian needs a buddy too, right? Be Brian's buddy. That's right, right here. Alright, I want to hear what Skylar and Melissa said. What's volume, what's surface area? That's how you find it, but what does that tell you? The inside. How much space is inside? How much, if you're going to fill up that cube with something, how much of that thing you can fit in? Okay, awesome. Keep going. What about surface area? Does anyone think they have a good definition of surface area? Eleanor? The what? Yeah, it's kind of the shell, the surface, right? It's kind of self-explanatory. Surface area. So if I take this block here and I kind of like unfold it, okay? How many surfaces do I have? Well, I've got 2 greens, 2 blues, and 2 reds. So if I just find the area of each of those and add them up, guess what I just found? Area. So kind of like in the last example where we're saying this would be how much grass and this would be how much fence. Let's say I have this box here and I was saying, hey, how much water could I fill in this box? I don't know why you put water in a box. Or how many things of something could you put in it? That's volume.
Like a fish tank, how much water?
Yeah, that's a good example. But now if I'm thinking of like, this is a present and I'm going to wrap it, the surface area is how much wrapping paper do you need. If you're going to paint it, how much paint do you need? Because you're only going to do that on the outside, not on the inside. Alright, so what we're going to do a lot today is we're going to talk about how we could estimate volume of objects using shapes that we know. Now if you go back to this shape sheet that I gave you, look at your 3-dimensional shapes. The most common ones that we're going to see are cylinders, spheres, cones, pyramids. We're also going to see prisms and solids, things like that, okay? Now, I grew up playing with Legos. You guys like Legos? No? Yeah, it's not fun to step on. You're right there. But I love building them. I still get Legos for my birthday because I like building them with my kids. It's fun. Don't give me that. She gave me a crusty. She's like, psh, what are you, 7? All right, whatever. I enjoy it. Now let's talk about Legos here, okay?
Off the bat, the head's part.
Well, hold on. Let me ask the question before you answer it, okay? What we're going to do is let's just focus on the head of this minifigure here, okay? If I wanted to estimate how much volume is needed for this minifig's head, what shape on your shape sheet would be a good shape that matches the head here? You guys agree? cylinder?
No, it's a cylinder. It's a squished cylinder.
I heard someone say sphere too. Sphere would be a good estimate, but would a cylinder be a little more accurate?
Yeah, because it has little cylinders as its neck and a little one on top for its head.
So I'm going to try to draw this. So there's a big cylinder here. And then Eleanor is saying there's a little cylinder here and a little cylinder here. So if you got hired as Lego and by Lego and they said, hey, I want you to estimate that, you would find the volume of the 3 parts, and then what would you do? Add them together. Now, if you played with Legos before, are they like solid all the way through?
No, because the heads are detachable. You can take the arms off, you can take the legs off.
So with this, what if we were doing surface area? Now this is where we'd have to use some reasoning. We're not going to find it here, but the surface area, do I need to include the bottom of this circle since it's already part of the big cylinder there? Like if I'm looking at the shell, I might take off parts of this. Like for example, I don't need this bottom part here because it's hollow. It goes in on the inside. So anyway, it's just getting you to think about how the shapes change when we're looking at it. What you're going to do is I'm going to give you 2 minutes, and you're going to come up with the rest of the body here. What 3-dimensional shape could be used for the legs? What about the torso? What about the arms? What about the hands? Okay? And use your drawing skills and see which shapes would be good matches here, okay? Just give you a couple minutes here and do some fun artwork here. Collage of shapes. Okay, give you maybe 30 more seconds, we'll come back. All right, let's start with Antonio. Antonio, will you just tell me one shape you used and for which part? Yeah, so it's almost like I would need to do like a big cylinder on the outside and then a little cylinder on the inside, right? But I like how you said, but it's kind of cut off. There's this part right here. But if you did like one inside the other, that's a great way of thinking of the hands. Cool. Let's then go to Oscar. Oscar, give me a different one. How could I represent a different part of his body? Yeah, these are, on the notes it calls it a rectangular solid. These are also known as rectangular prisms because, yeah, it's going to make kind of like a box. We don't really see that third dimension here, but it kind of comes back like that. Okay, so that's cool. I like that. So we've got the legs and the hands. Okay? What do you think, Eleanor?
Arms are pretty tricky, so you could use 2 rectangles and a little triangle to connect them. Because they're bent. And so you've got like a rectangle and a rectangle and like a little triangle or cylinder.
Alright, so you could do, you're saying do a rectangle and a rectangle. That would make them pretty boxy. Is there maybe a different shape we could use there? Could we use a cylinder instead of that rectangle here?
Then you have the curves, so you probably have to do like
Yeah, it won't fit in perfectly, right? That's why we're just estimating here. So yeah, you could throw in some different shapes too. I like the idea of a cylinder because it gives him that nice round look. And then what about for his chest?
Huge. It looks like a huge, what's the word?
Yeah,
Yeah,
it's like a three-dimensional trapezoid. That's not on your list, but I think that's a great way to model it. Okay, so kind of the idea is here it says we're going to do problems in the future, just in the next little bit. We're going to have to take a picture of something and try to say, well, what shape best models that? And try to go from there, okay? So let's actually jump now down to an actual Lego brick. So this is called a brick. And as was pointed out, you don't want to step on these. They don't feel very good, right? Not pleasant on the feet. Now, a brick is actually, if we're going to make the volume here, again, I'm going to give you 30 seconds. I want you to turn to your neighbor and say, how could I break this down into different shapes? What shapes would this be comprised of? Talk to your neighbor. Hey, I'm going to have Louise tell me. What were you saying, Louise?
You could take off like the cylinders on the top
Uh-huh.
and just use the bugs.
Yeah, so we have this. What shape is this going to be called, guys?
Rectangular solid.
There we go. So we have this rectangular solid, which we know how to find the volume of that pretty easily. That's length times width times height. So if I just multiply those together, I would get the volume of that, which is going to be most of it, right? Length times width times height. And then you said there's a bunch of little cylinders. How many little cylinders are there?
There's 8.
Okay, look at your formula sheet. What is the formula for the volume of a cylinder?
It is, the volume is pi r squared times the height.
There we go. So we're going to look at the area of the base. Since the base is a circle, that's pi r squared. Then we times it by the height. Okay, so let's actually do those calculations here. When I'm looking at the dimensions here, for the rectangular solid here, what is the length? Looks like it's saying it's 5/4, right? The width is going to be 5/8. And then the height is 3/8. So if I want to figure out the volume, I'm just going to get my calculator to do all that hard work for me. But I'm just going to take 5/4 and multiply it with 5/8 and multiply that with 3/8. Now we're going to get some small numbers here, and that's because Legos are small, right? This is like an actual size. But I get that the volume of that is going to be 0.29, and this is going to be cubic inches, because when we're measuring area, it's square feet, and when we're measuring volume, it's cubic feet. My heavens, they should not be in the hallway. I'm like tempted to go yell at them. Okay, let's now go to the cylinder. We said it's pi r squared h. Now when I'm looking at, I'm going to kind of draw a bigger version of it so we can see it a little better. I'm told that the diameter here, that's the whole way across, is 3/16. But we don't want to use the diameter, we want to use the radius.
What's half of 3/16?
That's a good question. What is half of 3/16? Well, let's just put the 2 in the denominator with it. It's going to be 3/32, because 16 times 2 is 32. Does that make sense? So the radius here is going to be, I'm going to draw a little note here, that's 3/32. And as far as the height, I'm told that the height here is 1/16. That's what this was right here, it's 1/16. that's going to come right there. So now I'm going to write out the volume here. I'm going to get the volume of one of the cylinders is pi times our radius squared, but our radius is 3 over 32. I'm going to square that. And then the height is 1 over 16.
And then once we have that, whatever that is, we can multiply it by 8. Because there's 8 little. Lego would look weird if it's that long and only has like one center. I don't know how you attach anything to that.
Alright, when I put that in my calculator, guys, I got the volume of one of those little cylinders is 0.0017. How many of those do we have? So I'm going to then say, so that's just for one cylinder. So if I'm doing 8, I'm going to times that by 0.0017. And that's going to give me 0.0138. Okay, so then to get the total volume here, we're going to need to combine the rectangular prism with our 8 cylinders. So if I do 0.29 plus 0.0138, that gives us 0.3038 cubic inches. That's how much plastic is used on one of these bricks. Now that's of course assuming that they are solid plastic. Are they solid plastic? No, but we're not going to worry about that too much. Okay, do you see my general strategy here? We took this brick and we broke it down into a rectangular solid and then 8 little cylinders. We found the individual volumes and then added them all together. That gives you the total volume. Is that something you could do on your own? You've got the formula sheets, so you don't have to memorize everything. You just need to analyze it and figure out what the radius is, what the height is, and things like that. Okay, let's talk about something else that's really fun. We've talked about Legos, we've talked about Mario. Now let's talk about cake. Making me hungry, right? Okay, here's what I want you to do, okay? Here's a cake, and someone snuck to it before everyone else did, and they sliced off a piece. Before I do anything else, I want you and your neighbor to try to estimate what % of the cake is still left. If they took off that one piece, how much is still remaining of that, okay? Talk to your neighbor. I'll give you 20 seconds. All right, let me hear an estimate. What did you think here? Who wants this one? Emma? All right, so you think this slice that they took out right here, that was about 20%? What do you guys think? Would you agree with that? So this remaining piece is about 80%. I would say that seems about right. Let's go with it. Notice it says estimate. Or about what, okay? So we're estimating, we don't know the exact. Now, if we were to try to figure out the volume of this, what shape should we use?
It's a huge black cylinder.
Yeah, it's a cylinder, right? So let's go through and let's figure out what the total volume is for this cylinder. And then if we're trying to figure out what amount is left, let's just figure out what 80% of it is, okay? Okay, so Jade, what is our formula for volume of the cylinder? Awesome. So looking at this, let's figure out first, okay, I need to know what the radius is, and then I'll need to know what the height is.
We're good in the diameter, which is 10 inches, and the height, which is 5.
Okay, so let's label that here. So the diameter all the way across is 10. But we don't want all the way across, we just want halfway. So what's half of 10? Alright, so our radius is 5. Now as far as our height, it tells us that the height is 5 inches. So we're going to plug this in and say, alright, so the volume is pi times our radius, which is 5, times our height, which is also 5. So I'm going to go to my calculator and put in pi times 5 squared times 5. And I got that there is 392.7 cubic inches of delicious cake. I'm going to put a little note. That's how much total cake there was until someone came in and stole a slice. Now, Emma, what percent did you say was still left? How do we figure out what 80% of 392 is? Do you know how, Emma? We did this for ACT practice not too long ago. We just needed to times it by 80%. But when we're doing that, what do we have to remember to do first? We don't times it by 80. 0.80. So we have to change. We need to go from 80%. We're going to move that decimal up 2 places. So what we're going to do is let's take that 392.7 and we're going to multiply it by 0.8. And that will tell us what 80%.
314.16.
It's almost like pi, get it, 314, but it's a cake. Oh, that's too silly. Okay, so this is how much remaining cake there is. Remaining cake. So this was a good practice. Not only were we doing estimating with shapes and volume, but then we had to throw in percentages with it. You feel okay with that? Alright, let's keep on rolling. If you have questions, please stop me, but this is the kind of stuff you're going to be seeing with this. Okay. Are any of you farmers or part of the, what's the agriculture club here? FCAA? Isn't that what it is?
No, I don't.
Anyway.
Don't ask.
Well, back in the day, when people were farmers, and there still are, we're just not here, they would store all of their grain or all their oats or whatever in these giant metal containers called a silo. Okay, I want you to take 20 seconds. Well, first off, look on your formula sheet. Is there a formula for silo?
No.
No. So what I want you to do is look with your neighbor. What shapes could make a silo? Only need about 20 seconds. Here, go. Oscar, what do you think? So yeah, I've got a cylinder right here.
And it's home.
And yeah, so if we're looking 2-dimensional, it kind of looks like a triangle, but if it's in 3 dimensions, let's actually call that a cone. Let's change colors right there. So here is my cone. It's going to go around like that. Thanks, Oscar. Alright, so then what we're going to do, if we're trying to figure out what is the volume of one silo here, let's figure out what is the volume for the cylinder first, and then we'll come back and do the cone after, and if we add those together, that should give us a total volume of this silo. Alright, so Caroline, you're going to help me with this cylinder first. What is our formula for the volume of a cylinder?
Pi r squared and then h.
Alright, let's read through this and see if we can figure out any of that. Alright, the diameter of the silo is 24. So if I'm going all the way across, that's 24. How does that help us?
Because you need the radius.
And the radius will be
12.
half the diameter. So I'm going to put a little note here. The radius is 12. So here, there's 12. We just read the next bit. It says, and the height of the cylinder is 51. So that's 51. So I'm just going to put 51 right there.